Hello everyone, welcome to lecture 5. In this video, we're going to cover the basics of Python programming. So let's get started. So we're going to cover some software tools to help us work with Python, such as Anaconda, Jupyter Notebook, and then the basics of Python programming, including the variable, data type, and the control flow and functions, which help us to write longer codes, and then the common packages used for data processing or machine learning. All right, so typically we use Anaconda, which is a tool to help us manage the different softwares, programs, and the environment as well. So we can just Google Anaconda and then search for the corresponding installer that corresponds to our operating system. Just note that when we install the software, we need to install for the computer or laptop we use, right? So we can gain access to the admin privileges in terms of installing particular packages. If we install for user only, then it will cause an issue. An alternative way is to use the online Jupyter Notebook, such as Colab, which saves us the need to install the software. The main reason we use Python for this course is really one is the high readability and the simple syntax, and also the strong support in terms of the open source libraries for us to use when dealing with the financial data. Right? One example is we can put a string here. I love Python and machine learning. And this \n really means to have to change to the next line, right? And then we put it for 5 times means this repeats for 5 times, and then which corresponds to printing this sentence for 5 times. So there are quite many commonly used packages. For example, numpy and pandas. So these are the common packages we'll be using in this course. The programming environment is mainly Jupyter Notebook or Jupyter Lab, which is another high-level wrapper of Jupyter Notebook. The main interface is something like this. So we have a cell. This could be a code cell, which means we will write code here. Or it can be a markdown cell. Markdown cell means that we're going to write documentation. Right? So it's one thing to write codes, but also another thing to have good annotation, good comments for the code, so that it's the logic is clear and it's readable by other people as well. Right. So we start with a variable. Now, a variable is something a placeholder we use to store something. For example, we can use this equal sign, which is called the assignment operator, to assign a value. So this is the value of the variable, and this is a variable. And when it is a variable, we also call it an object, right? Then the object has its own attributes and methods we can call. There are some system built-in functions like the print, which means you can just use it to print. But then here in this case, 10, there's no variable to store the value. So once we print it, then it's gone. And also when we assign a value to a keyword, so print is a keyword in Python, that means that it's no longer serving as a function for us to print. Then this will give an error because it's no longer treated as a function to print us something, just a variable. So the key takeaway here is that when you assign a variable, do not override the system built-in functions. There are some rules as well. For example, the variable name should only contain one word, the whole word with no space in between. It can contain the letters, numbers, or underscore. Cannot start with a number, and again, avoid using the keywords. There are quite some data types. The common ones would be integer, which is just an integer number, a floats, a Boolean number, which is often used to determine either a certain codes are executed or not, right? It takes a value of true or false. A string, just the common string we have here. A list is a more complex structure. It takes several elements together in a list. So list is identified by these square brackets here. And then whatever goes inside can be one or multiple, right? And it can be a string, it can be an integer, etc. A dictionary is more flexible. Dictionary is something in the form of a key value pair. So this is a key, this is a value. This is just like an index of a book, and then this is actual page. And we have this comma sign here to denote the relationship, and key value pairs are separated by the comma here. And then if we see curly brackets, then it means it's a dictionary. ndarray, which is from numpy package, it serves as an n-dimensional array, right? It could be one-dimensional array, which is similar to a list, two-dimensional, which is a matrix, and if it's three-dimensional, then it goes into something called a tensor, right? Okay. Last we have the data frame, which is meaning from pandas, and is actually the main data type we'll be using to work with financial data, right? Because think about vertically along the rows, we have different days, and columns will have different price points. So that's Excel like 2D table. We have a list of operators. So an operator is something which we use to operate, to perform specific operation. So for example, we can do the comparison, like bigger than, less than, etc. And all these operators evaluate to true or false, right? So that's the comparison operator. Again, it's used to have a set of condition for comparison. Logic operator chains together multiple conditions. For example, we want to say if both conditions on the left and the right of the AND operator are true. So it will only return true if both are satisfied, both evaluate to true. And we have other operators like or not, which so or is as long as there's one true, then it returns true. And not means that we're going to do the reverse of the results. Let's look at control flow. So control flow comes in when we have multiple conditions together, and we want to say if this happens, then execute something. If not, then execute something else. So here, really the key portion to pay attention to is that if you look at this this if else control flow here, we have two conditions, so 1 and 2, and there are 3 branches really. So first branch, second branch, and third branch. So if the first branch, the condition is satisfied, then we execute the main body. So this is identified by having this additional indentation here. So usually we go with 4 spaces. So this requires 4 spaces. And then if this evaluates to true, we would execute this portion. And then if not, we will go to condition 2. So this process is really sequential. So first evaluate condition 1, second evaluate condition 2. So the sequence of these conditions is also important when you design your control flow. All right, we can also write it as a concept swing like this. So the way we read this is if condition evaluates to true, we would return value 1. Otherwise, we would return value 2. So this is helpful, it's handy when we only have one condition to evaluate. But as soon as the condition gets more complex, then we'll do something like this. Functions are a way to help us do packaging, right? So when we say something itself become more complex, and we want to package it so that we can treat it as a black box, just call it. So there are already built-in functions like the print or the type to return the type of the data. And we can also write our own customized functions identified by the input and output, which again, both are optional. Right. So this is just to show you some defaults functions. And again, the returns are optional. So type return has a return. It returns the type of the data type, but also the print itself, there's no return. It just prints the message to the console. Let's look at the strings. Strings is really a collection of characters, right? And these are zero-based indexing. So if you want to index the first letter, we would say square brackets and then index 0, right? So this is how to index it, or slice it or subset it. We can call a list of system built functions, for example, len, to get the length of the string. And we can say just by passing the index separated by the colon to guess the subsets of the string. We can use the in to say if some string is contained inside another string, and we can concatenate two strings using the plus sign here. Let's talk about the list. So the way we access the list is very much similar. We use the square brackets. So for example, here we have list, John, Jane, and we just say we want to access the second entry, and we pass in 1 because 1 corresponds to the second entry. And we have the function length to return the length, and then we can do the subset a sequence of elements, do the evaluation in terms of is this element is contained in the list, and also do the expansion of the list. So this means that we want to append additional entries to the list, right? So let's look at dictionary. So dictionary, there's no ordering, right? So the way we maintain we access the entries would be to use the keys. So this is called the key, this is called the value. And then again, we use square brackets to put in the keys. This will return the value of John, right? We can also do the overrides. So we can say we can access this value, but we pass it. This is assignment operator, right? We pass it a new value, then this new value will get updated in the existing dictionary. So that's to replace the existing values. If the existing key is not in the dictionary, then it will automatically create a new entry with this new key and value. So this is to update the dictionary. All right, so lastly, let's look at the packages. Install package by pip install. This is one to install. And Anaconda, using Anaconda, can also just by click a button, install the packages. That's also fine. So before we use the package, we need to import it. So in this case, we want to use numpy. Let's say import numpy as np. So this is an alias. Then downstream, we can just use np. So in this case, numpy, we have different dimensions of array. So one-dimensional array takes in the list, the one-dimensional list, and then converts it to an array. So this is a function. A two-dimensional array is arranging multiple lists together, right? Then in a two-dimensional way, and then three-dimensional array really adds one more dimension by stacking two-dimensional arrays, right? So this the dimension continues to go up, and we can call a list of attributes to get some information about the array. For example, the number of dimensions, and the shape, size, and the data type. When it comes to data processing, the way we access the elements is mostly similar. So we can use the index, right? Depending on the dimension of the arrays, we may use multiple indices. It's basically what works similar to how we access the lists. And we can use a series of built-in functions to access the summarizing the statistics such as the mean, the max, standard deviation, percentile, etc. And note this is using the numpy functions. This is using the methods of the object itself. All right, so we can do elements-wise operation just by, for example, here we have an array here, and then we just plus 10. So this 10 gets added to each element in the array, and that's because we first broadcast. So this is broadcasting mechanism. We broadcast 10 into an array of 10, 10, 10, right? And then we just get element-wise addition. Note that the broadcasting itself may not work every time, so we need to make sure that the dimensions check. So, for example, in this case, we have a two-dimensional array, and want to add to another one-dimensional array. So what happens is that by default, this array will get duplicated along the vertical axis, right? And then we can do the elements-wise multiplication addition to get the results here. Next, we look at pandas series. It can be treated basically as a column in the table. Right? So it's itself is a column, it's a series. It could be a time series, etc. And then again, we built a series based on a list or an array. And then there are several attributes: the index and the values. Right. So the index tells me what is the identifier. For example, it could be integers by default, or it could be dates when we work with the time series data. And then the values are just price for that specific entry. We can design our own index and use the same approach to access the elements in the series. So this is by location, this is using the index, and this is to access multiple entries in one shot. So this also we call the position-based indexing, and this is called label-based indexing. So we also commonly use DataFrame to work with two-dimensional data, something like this. And as mentioned earlier, we can use the conversions. We can build a DataFrame by converting the dictionary. So first we build a dictionary here, right? The key and the value, which is list. And then we can wrap it as a dictionary, then convert it to a DataFrame. Right, so there are a list of attributes for DataFrame. So this to get the column names, this to get the index, the shape, and the size. So we can override the index as usual, just like series, and access a column by passing in the specific column name and access the column. We can also pass in multiple column names wrapped again in a list, and then do the subsets. So that's one way to do the slicing. There's another way which is also quite commonly used, is to use the log and alloc properties or attributes, right? So for example, log is really label based. So this is to say I want to access the row whose index, right? Whose label is this string or date, and then also so this is row level, this is column level, column dimension, and want to look at the column whose name is Tesla, right? So we can do multiple days, multiple columns as well. So ilog, the I really is index, right? So it's more position based. So to say second row, right? One means second row, second column, want to access the elements. and multiple rows, multiple columns. So this gives us a way to access the elements of the data frame without specifically mentioning the labels. Okay, so there's more we can do about subsetting the data frame. For example, we can add a condition here to say if the condition is satisfied. For example, if the stock price of Tesla is above certain threshold, now this returns a series, or in this case, a data frame of true or false, right? And then we can pass this condition inside a log property, and then this will be used to do for us to do subsetting, right? To do row level selection. So this to say we will look at which rows, the rows whose test price is above this one, and then we return the data frame the rows which satisfy this condition. So really, this is doing the row level subsetting based on specific user-defined condition here. And then we can throw in additional operators at the logical AND, logical OR, or logical NOT, so that we can have multiple conditions together to do this selection. And here the backward slash really means that once our line of codes is becoming very long, we can use this to change the line, and it tells Python that this is just still one line instead of treating it as 2 lines. And lastly, we have file in and outs, right? So read in, usually we use the read underscore something. It could be a CSV, could be Excel, etc. And then we can have additional parameters to say which column we treat as an index. And if it's Excel, okay, so if depends on the different operating system, we would specify differently according to how Python treats the underlying path convention. Then once we have processed data, we can save it using the tools CSV function. Right, it's also good to have a copy of the data which is clean and then can use for further downstream task. All right, so that's it, and thanks for watching, and hope to see you in the next video.